Hi friends, welcome to the Unit 4 Day 3 notes. This one focuses on logarithms. Logarithms are defined if you have positive numbers, so here x and b can't be 1. So this right here is an equivalent representation of both. So if you have y equals log base b of x, if and only if, and that's what that IFF stands for, x equals b to the y power. So these two are interchangeable. They mean the exact same thing. So if you say b to the y power equals x, then log base b of x is equal to y. So kind of an example of here, this is asking you to convert between the two different forms. So pause the video now, try to go, using this as kind of a guideline or example, try to convert these. You could use this background space off to the sides just to see if you kind of have the idea of the conversion going back and forth. So jumping in, this is 3 to the 4th power. 3 is the base. So whenever we talk about like what the base is, so this is log. How do I do this? Log base 3. So there's a 3 of 81 equals 4. So log base 3 of 81 is equal to 4. And that means 3 to the 4th power equals 81. Similarly, you can go the other direction. So 1/2 to the negative 3rd power equals 8. And you know that's true. You could verify. 1/2 to the negative 3rd power does in fact equal 8. Then the next one, log base 10 of 1000 equals 3. And then this one converting back, so it's 5 to the negative 3rd power equals 1 over 125. Then here, log base 12 of 12 is equal to 1. That's something to note. So log base 12 of 12. And then converting back to exponential. So 6 to the 0 power equals 1. So one thing to note is that if anything is to log base any number to 1, you will always get 0, and log base a number of a number is always equal to 1. So this down here talks about the expression log base 10 of x is referred to the common log, which we just call the log of x, so we don't use that 10. And then if we want to talk about the natural log, so we use log base e, then we will abbreviate that ln, natural log ln of x. So basically what you have here is if it doesn't have a base, so no base was written, then it's base 10. So if you don't have a base written, then it's base 10. And then if you have ln, that's always base e. Example 2. Determine the value of a logarithm without using a calculator. So here, what I'm going to do is I'm going to convert this to an exponential. Convert to exponential form. So for here, it's my base in this case is x, so it's x to the 3rd power is equal to 8 over 27. So in this case, again, you need your bases to be the same, so I need this base to be the same. So to do that, I can take the cubed root of both sides. So if I take the cubed root of this and the cubed root of this, so this is the same as if I took the cube root of the numerator and the denominator. So I'm going to have x equals the cubed root of 8 and the cubed root of 27. Both of these simplify nicely, and I get x equals 2/3. So in this case, x equals 2/3. Now for number 8, let's see, this is 16 to the, looks like 3/4 power is equal to x. I think it's easier. Remember that you can take, when you raise it to the 3/4 power, that's the same as taking it to the 4th root. So I'm going to do that first. So I'm going to have 16 to the 4th root and then cube it. Let me show this. 4th root of 16 and then cubed equals x. So the 4th root of 16, so that's going to be 2. And then I have 2 cubed. 2 cubed is 8. Number 9, log base 36. So I'm going to have 36 to the x power equals the square root of 6. I think it's easier to see this as exponential form. So I'm going to convert the square root of 6. That's 6 to the 1/2 power. So I have 36 to the x. So I just need to convert 36 into 6 squared. So I have 6 squared times x equals 6 to the 1/2. So now all that I need to do is just simplify, set 2x equal to 1/2, and then solve. So divide by 2, and I get x equals 1/4. And then this says determine the value of a logarithm with a calculator round to 4 decimal places. Most times when you see this, it's going to give you an irrational answer or an irrational number for most of these. So in your calculator, the log here is this key right here on your calculator. So it's about 4 up from on. So here I'm going to do log of 47, and you see that mine has an open parentheses, so I'm going to go ahead and push close parentheses. I always do that. There's going to be some times later on where we're going to need to, practice the open and close parentheses, so we're going to need to do that. And so this is 1.672. All right, and that 0, the next number is a 9, so we're going to round that up. Now, log of -5 is going to give us a very interesting result. Oh, I need to turn off real. There we go. I had it set so that it could give me non-real answers, but this is not a real answer. This is going to give you an imaginary answer, and the reason is because you can't take logs, similar to what we talked about on the previous page. You can't take logs of negative numbers. So this is non-real. We're just going to leave it like that. I had my calculator set to complex mode. That's why it said A plus BI. If you rewind back, you can see. But this is non-real. For logarithms and what we're going to do in this course, we only want real answers. We're going to be getting into practical applications of them and then graphing. And for this course, you're only going to focus on that. There are other courses where you would need to know the complex form, not here. And then the natural log, the natural log of 0.75 gives me this. So now, so that's -0.287. The next one's a 6, but the next one's an 8, so that rounds up 7. Okay, so I want to point out a few things. One, we can't take natural logs of negative numbers. Notice the base here. The base is 10, 10, and e on these. So it's not the base that's the issue on this. It's what we're using and taking it of. So this is when you have a positive log of a positive number. So log base 10 in this case. It could be any base of a positive number. We get a positive result. We can't take the base. sorry, we can't take the log, excuse me, of a negative number, we get a non-real answer. And then if we take the log of a number between 0 and 1, that's how we end up with a negative result. So between 0 and 1, that's how we get a negative result. So positive because it's greater than 1, negative between 0 and 1, and if it's a negative, then it's not real. In the next video, we'll actually talk about graphing. I'll see you then. Bye, friends.